Okay, we'll see problem on trains. In problem on trains, we'll see some basic formulas. So in basic formulas, first thing is how you convert kilometer per hour into meter per second. Okay, so before going into how to convert this, let's take some basic problem. For 2 rupees, you are getting 8 chocolates. Okay, then for 6 rupees, how many chocolates you will get? To calculate this, okay, the simple thing you have to do is multiply these two things, okay, and then divide by this one. Okay, so this will be 3 times, which is 24 chocolates. So how this came is, see how many times here, how many times it has increased here. This has increased 3 times, which is 6 by 2 times, correct? Same quantity only would have increased here also, right? So 6 by 2 times it has increased, right? So here also 8 into 6 by 2, that many times it have increased. That is how this one came. If you can't remember this, just remember this one. For 2 rupees, 8 chocolate. For 6 rupees, multiply this and divide by this. Okay. Similarly, here, right, so 8 kilometer per hour, you have to convert to meter per second, correct? So first convert kilometer to meter. To convert kilometer to meter, you have to multiply by 1000. So in divide hour is there, right? Divide hour is there. Here hour is there. To convert hour to second, you have to first convert to minute. To convert to minute, you have to multiply by 60. And to convert to second, another 60. So basically, you have to divide by 60 into 60, right? So which is 8 into 1000 divided by 60 into 60 is 2 cybers and 3600. This one and this one cancel. In 2 tables, this will be 5 times, this will be 18 times. Okay, so to convert kilometer per hour, you have to multiply that value into 5 by 18. That is how this came. Kilometer per hour to meter per second. Similarly, to convert meter per second to kilometer per hour, you have to multiply by 18 by 5. Okay, this is the first formula. The second is the time taken by a train of length L meters to pass a pole. Okay, so you have a pole, you have a train. Okay, this train length is L meters. So the time taken by a train of L meters to pass a pole or a standing man or a signal post is equal to the time taken by the train to cover L meters. Okay, so this is a train of length L meters. Okay, so to cross the pole, right, the train has to travel actually L meters this side, right? This train length is L meters. To cross the pole, the train has to travel L meters. So the time taken by the train to cross the pole is equal to the time taken to cover L meters. That is what you are saying here. Okay. The second is the time taken by the train to cover of length L meters to pass a stationary object of B meters. So now it's a, instead of a pole, you have a stationary object. Okay, this is length is B meters. Now you have a train. Okay, I don't know how to draw a train. Okay, let's put on could be here. Okay, so this length is L meters. Now the time taken by the train of L meters to cross the object of B meters is the train has to completely cross this B meters, and then again one more L meters it has to cross for the train to come over this side. So the train has to cover L plus B meters, right? So the time taken by the train to cross the stationary object is equal to the time taken by the train to cover L plus B meters. Okay. Second train is the two trains or two objects are moving in the same direction. So one train is moving in the same direction, another train is also moving in the same direction at u meter per second and v meter per second. So this train velocity is u meter per second, this train speed is v meter per second. So u is greater than v. Now the relative speed compared to this train, what this train is moving, the relative speed will be, since it's moving in same direction, it is u minus v. If the two trains are moving in opposite direction, like one train is moving like this, the other train is moving like this is u meter per second and this is v meter per second, and that time the relative speed will be u plus v meter per second. Okay, now if two trains of length A meters and B meters are moving in opposite direction. Okay, so there are two trains. Okay, one is A meter length and other train is B meter length. They are moving in opposite direction. Okay, and in velocity U meter per second and V meter per second. This is U and this is V. Okay, now the time taken by the train to cross each other, for this train to come like this, to cross, what is the time taken? This will be this. Always remember this: speed is equal to distance by time, right? So time will be distance by speed. So total distance will be A plus B. The time taken will be A plus B divided by the relative velocity. Since it's moving in opposite direction, relative velocity will be U plus V. If it is moving in same direction, the distance is same, time taken, the distance will be same, but the relative velocity will be U minus V. Okay. Okay. Now the 10th point, if two trains start at the same point A and B, one point is A, other point is B, and move towards each other. Okay, they are moving like this. They are moving towards each other. And after crossing, okay, so this train, this train has crossed. This is a train. Let's assume this is a train. It started from B. This is a train. It started from A. Right? Now, after crossing, they take A and B seconds to reach B and A. So after crossing, they take A second. And similarly here, after crossing, it takes B second to reach A and B points. Okay. Now, the ratio of their speed, okay, the ratio of their speed, the A speed by B speed, or A speed is to B speed, will be equal to root B is to root A. Now, what is B? B is the time taken by this train, right? B is the time taken by train started from A in reaching point A, right? From B, one train has started, and after crossing here, it takes B second to reach A. Okay, so A and B are time taken by the trains to reach the points A and B after crossing. So this is the ratio which is true.